Kudeja, are you there?
Yes, sir.
Let's start with this. Please do send me the answer in chat box, and accordingly I will check it and then explain if there is any error.
Yes, sir.
to do this. I think you can do this question easily. Kudeja, have you revised this chapter?
Sir, what is triatomic species?
Triatomic species. In which of the following? Where is triatomic species? Oh, three atoms.
Okay, sir.
Triatom means three atoms in a species or compounds.
Yes, sir.
Oh, very good, Akif. 58 is correct. So there's a what about you if you're not able to solve or if you haven't revised this chapter? I think you were absent in the previous class, right? So there's a Very good, Akib. You are doing good. Sudhir, are you there? Please do respond. I need to talk to you. Very good, Akib. Keep going. Not getting 61. Okay, 61 is very easy. If you're going to see, which of the following is not isostructural with SiCl4? Very simple it is. Silicon is 14th group element, right? Yes or no?
Yes, sir. Yes, sir.
So, can you tell me the lone pair present in silicon? Silicon in 14th group element, it will have lone pair equals to 0. Yes or no?
Yes, sir.
And bond pair equals to how much? Bond pair will be equal to 4. So go for the elements which has same scenario. Lone pair should be 0 and bond pair should be 4. That means total sum will be equal to 4. Okay, with lone pair 0. There is must, that is lone pair 0. And if you are going to see, if you are going to check, there is no lone pair in SO4 and there is 4 sigma bond. In the same way, there is no lone pair 4 sigma bond, no lone pair 4 sigma bond. So these all are isostructural with this except this SCl4 because sulfur is 16th group element. And when sulfur is making 4 bond, when sulfur is making 4 bond with chlorine, if you are going to see, so this is the scenario. And 16th group has how many electron in the outermost cell? 16th group has 6 electron in the outermost cell. That's why there will be 4 involved in bonding and one lone pair is there. So this is the correct answer. Got it? SCL.
Yes, sir. Okay, sir.
Deja Basir, please respond so that I will be able to know whether you have the concept or not. Deja, am I audible? Any answer? Pudeja? Very good, Arpit. Very good. What about 63? In 63, when you have BF3, all the atoms surrounding this central atom same. So in case of sp2, all the bonds are equal. All the bonds are equal. AlF3
Yes.
in the same way. It's basically ionic compound. It's also equal. NF3, if you are going to see, oh, wait a minute. Yeah. NF3, it's also equal. But when we are going to talk about ClF3, so if you are going to see the hybridization carefully, there is two lone pair. So hybridization is sp3d, in which we have two types of bond. One is axial and another is equatorial. This is your axial and this is your equatorial. So axial is longer than equatorial. That's why it will not have equal written at 64 I take. It will not have equal bonds. D. sp3d is very specified.
Okay, sir.
Okay. 64 that you get the answer is correct. So these are I'm requesting you to please do respond whether you are getting it or not. I will explain the concept if you are not getting. Any answer for 64? 64 done. 65.
No, sir.
Okay. No problem. If you are not getting it, just let me know. I will tell you. So in this 62, if you are going to see, B is the correct answer. NO2 plus is linear. sp hybridization, this is D. 64, which of the following molecules has trigonal planar? That means sp2. So we have 3 as sp2. The rest, this will be sp3, this will be sp3, and this will be sp3. And in the 65, if you are going to see, in BRF3, BRF3, I'm going to show. This is your BRF, and two lone pair will be there, right? Two lone pair will be there here and here. So what they asked, try to understand, that means this is a trigonal planar type structure, a geometry. Okay, but the structure will be different only because it has lone pairs, so there will be a repulsion and all. So they ask, we are afraid the lone pairs occupy equatorial position to minimize lone pair repulsion only, bond pair repulsion only, no, lone pair repulsion, and lone pair bond pair. See what happens if it is going to occupy this axial position, right? Sorry, equatorial position. Oh, BRF, fluorine F. Okay, so what happens if they will be like this, equatorial position? Okay, so see what will happen if you are going to draw the structure. Just wait a minute. Let me go on. It will be like this. Okay. So here lone pair is 90 degrees. So the repulsion will be very, very less. No, no, not 90 degrees. Yeah, you can consider it at 90 degrees. Okay. But if you are going to put this lone pair away from each other, like this and this. So fluorine, fluorine, fluorine. So now it is at what degree? Far away from each other. So the correct answer is your C. Lone pair repulsion will decrease, and lone pair bond pair repulsion also decreases. So that's why lone pair will occupy equatorial position. Is that clear?
Yes, sir.
Possible structure you can draw if you want to. Like first I'm going to draw like this, second I'm going to draw like this, and the third I'm going to draw like this. Lone pair here, and fluorine here, fluorine here, fluorine here, and here is another lone. Go for the next. Let me know if you are able to do this. Okay, I'm going to explain this as well. Very simple.
Okay, sir.
See, in an octahedral structure, octahedral, that means sp3d or d2sp3. Two types of hybridization is possible, d2sp3 or sp3d2. You will be able to understand and you will get every concept for this d2sp3 in class 12 complex compound. And right now I can say is that when bonding is taking place, in this case, the first bond is in s orbital, then 3p orbital. There are orbitals of p, which is 3, and 2d orbital. At the last, you are going to use this d orbital. So that's why sp3d2. And in case of d2sp3, this orbital is used first, d2, then 2 orbital of d, and then 1 orbital of s, and 3 orbital of p. That's why it becomes d2sp3. But both has a geometry, that is your octahedral. Both has a geometry, that is your octahedral. Okay, and In this one, D2sp3, what do we use is very simple. We use the dx square minus y square and dz square. You know that d orbital has five. D subcell has five orbitals, out of which we have dxy, dyz, dxz, dx square minus y square and dz square. So for D2sp3, we use these two. These all will be filled. So we are going to use this for D2sp3. Always remember this. Very important. Let me know when you are done. If you
Done,
will
sir.
draw the if you will draw the structure, then you will come to know this is your x and this is your y. Let's say so. It will be like this. The whole, like if it is y z, you will have this low between the axes. But if you are going to draw the dx square minus y square, this is your x, this is your y. So it is more directional towards x and y axis. This is your dx square minus y square. For dz square, if you are going to draw, let's say this is your z axis. So this is more directional something. So it will be easier to overlap with s or p. So that's why we have dx square minus y square and dz square.
Yes, sir.
Please do this. Let me know. Are you done with this?
Sorry, sir.
Are you able to do this?
Yes, sir. Done.
Very good. What about 67, 68, 69?
Doing, sir.
Very good, Akib. So there's a no answer from you. Are you there? No, that's the only one. Okay, no problem. See, very simple. If you know the geometry of this MX6, the octahedral, MH6 octahedral. That means sp3d2. Yes or no? There is no lone pair. So M,
Yes, sir.
X is here, X is your here, X is your here, and X is your here, and X is your here, and X is your here. How many 180-degree angles? So you can see first, you can see second, and you can see third. That means three. Yes or no?
Yes, sir.
Which of the following has p-pi p-pi bonding? P-pi p-pi d-pi bonding. First of all, nitrogen cannot be. You know why? Because it is second period element. So second period element doesn't have d orbital. This is also second period element, so it also not have. This is also second period element, it will not have. Third period element is possible, and this is the CR. Okay. And if third period elements are given and maximum, if it is in maximum bond, so there will be possibility of p pi d pi bond. Okay. As you can see, S has sulfur has 1s2, 2s2, 2p6, 3s2, 3p4, and then 3d0. D will be there, which is vacant. So for 3s2, I'm going to write the last shell. You can see 2 electron, and P, you can see 1, 2. So when it will be in ground state, it will have only two bond because two unpaired electron. So two bond it will make. When it will be in first excited state, let's say D now have 0. So when you are going to excite this first excited state, you can see how many unpaired electron are there. How many unpaired electron are there? 4. So excited state first will have only two bond in the ground state. Now we will have four bonds. Four bonds, that means four unpaired electron. That means basically covalency is 4. Now excited state 2. If you are going to excite it, we are going to excite this and it will be in this. So this is also unpaired, one bond. These all three are unpaired, four bond total. And now you can see how many bonds it is making, 6, including it is going to include d orbital. So here p pi d pi bond is possible. And oxygen is there. Oxygen is your second period element. So it cannot have d orbital, but p orbital in this is available. So there will be pi bond forming between p orbital of oxygen and d orbital of sulfur. So we call it p pi d pi bond. Is that clear?
Yes. Yes, sir.
Okay. Come to the 69. 69 is very easy. Main axis of diatomic molecule is Z. Let's say main atomic axis of diatomic molecule is Z. Molecular orbital px py overlap to form which one of the following orbital? Very simple. If this is your scenario, x, y, and main axis is your just outside your screen, let's say Z. So the overlapping here will be parallel overlapping. So when parallel overlapping will take place, then it is pi orbital, pi molecular orbital. Is that clear?
Yes, sir.
Okay. Can you change the slide?
Yes, sir.
Do this. I will be back almost. Any answer, Akib?
Doing, sir.
Again, 72 is similar. No, very good. Kudaja, are you there?
Yes, sir.
Are you able to solve this? No answer from you. Very good, Akib. 74 is also correct. Not 75. You know that ASF5 has a hybridization sp3. That means S is there and 3p, that means px, py, pz will be there. Is there any pz? No. So this will not be the answer. And out of dxy, dyz, dxz, dx square minus y square or dz square, we use dz square. So the correct answer will be C.
Okay, sir.
Is that clear?
Yes,
Pyramidal
sir.
structure, that means Very simple. Geometry should be tetrahedral. sp3 is your, what do we say? sp3 is your hybridization. So if you're going to calculate here CO3 minus 2, which has a structure like this. So if you're going to calculate the hybridization, it comes out to be sp2. For SO3, if you are going to calculate, again there is no lone pair, sigma, sigma, sigma. 3 sigma, again it will be sp2. Okay, for BF3, if you are going to see, again it will be sp2. sp2, that means trigonal planar. But if you are going for PF3, F will be here, F will be here, F will be here. And since it is 15th group element, there will be lone pair. So basically it will have pyramidal structure. So the answer is D. Is that clear, both of you?
Yes, sir.
Can I change the slide?
Yes, sir.
Please.
Okay, sir.
Do you say anything?
No, sir.
Are you able to solve this? Please to respond because you are only left in the class. Okay, I'm going to explain. Very simple it is. BCl3, if you are going to write the structure, you will come to know that lone pair is equal to 0, bond pair is equal to 3. So if you are going to sum it, lone pair plus bond pair, it will come out to be 3. That means hybridization is sp2. And if hybridization is sp2, that means it is trigonal planar. Come to NCl3. If you are going for NCl3, nitrogen is a 15th group element which belongs from 15th group. Nitrogen is an element which belongs from 15th group, 5 electron in the outermost. Now lone pair here is equal to 1 and bond pair here is equal to 3. Now if you are going for hybridization, lone pair plus bond pair, that will be equal to 4. That means hybridization will be sp3. And if hybridization will be sp3, then geometry is tetrahedral, but the structure due to this hybrid lone pair, there will be a repulsion in this. There will be repulsion in this and it will look like pyramidal. The structure will be pyramidal and hence BCl3 has no lone pair, but NCl3 has a lone pair of electron. That's why it looks same, but its structure is different due to the hybridization and the presence of lone pair. Okay. Now come to this. The distance between two adjacent carbon atom is largest in benzene. Benzene is something like this. I'm going to explain. This is your carbon. This is also your carbon. This is also your carbon. This is also your carbon. CH and again CH and then CH. And you know there will be double bond in this. There will be a double bond in alternate position. Then for ethene, there is CH2 double bond CH2. For butane, it is CH3, CH2, CH2, CH3. You have studied this in class 10. And for ethyl, triple bond. So if you can do this with the help of triple bond is smaller than double bond than single bond. That means single bond is the largest one. And you can do it with the help of bond order. Bond order inversely proportional to bond. So for this carbon, there is triple bond. So that's why it is having the smallest size. This is having twice double bond. Then it is greater than triple. And the largest is butane because it is having single bond. Single bond is largest. Is that clear? For this, among the following orbitals, the angle is minimum in between. sp3 bond is your 109 degree, 0.8 minutes. px py, that means this is your x, this is your y, so it will be 90 degree. H2O, you know, in H2O, the hybridization is sp3, but it is not 109 degree due to the repulsion between lone pair and lone pair bond pair. It comes out to be 100, approximately 90 plus, 90%. And for sp bond that means linear. Sp means linear. So it will be 180 degree. So the lowest will be 90 degree px and py. Which of the following does not have a tetrahedral structure? That means does not have sp3 hybridizer. H2O, just now I told you sp3. And as for positive, 0 lone pair, 4 bond pair, sp3 it is. BH3 is your sp2, BH4 that means sp3. And BH3, I just told you, BF3, BH3, this is the scenario. It will have sp2 hybridizers. It will have what? sp2 hybridizers. So I hope this is clear to you, Fudeza, Bashir. Akib, are you there?
Yes, sir.
I just explained all of this and give the answer. Yes, yes, yes. Let me know if you want me to again explain this.
No, sir. Clear.
Thank you. Move to the next part of the question. Oh, we already did that. So moving to the next part. Yes. Any answer? Very good. 81 is also very easy. Okay, very good. Very good. Go for the next one. So very simple it is. If you are going to see chloromethane. Okay, it is three hydrogen will be there and one chlorine will be there. Then carbon tetrachloride, that means iodoform CHI3, that means chloroform CHCl3. So see, in this, all the bonds will be equal only in one case when all the surrounding atoms are same. So this is the answer, carbon tetrachloride. And why it is so? See what happens, there will be difference in electronegativity. So there will be delta positive, delta negative. So that's why there will be force of attraction in different bond length. Okay. And different bond lengths, so also the angle changes. That's why carbon tetrachloride is the correct answer. Is that clear?
Yes, sir.
Going to change the slide. Very easy it is. Yeah, sigma bond is always stronger than pi bond. That's why. But double bond, when we are going to talk about double and single, this will be a strong. But when we are going to talk about sigma and pi, this is strong. I hope this is clear to both of you. applies to this as well. Very good. Go for 86. It's also very easy.